look at our table and let's try to do the 0 row. Well, we'll do the 0 column. So if I fold in my 0, sine, how many fingers do I have above that one? So the square root of 0 divided by 2 is 0. Cosine, how many fingers do we have below?
4.
So the square root of 4 divided by 2 is?
1.
Tangent, square root of the top over square root of the bottom. So square root of 0 over square root of 4 is 0. And if you have those, how do we get the rest? Reciprocals. So cosecant is the reciprocal of sine. So the reciprocal of 0 is? Okay, cosine and secant are reciprocals. The reciprocal of 0 is, or of 1 is, and then tangent and cotangent, reciprocal of 0 undefined. Okay, so now let's look at our 30. So if you fold in your 30 finger, sine, the square root of the top divided by 2 would be cosine, the square root of the bottom over 2, tangent, square root of the top over square root of the bottom. So radical 1 over radical 3, which would simplify to radical 3 over 3. All right, is everyone understanding how I got those? So the rest are reciprocals. So reciprocal of 1/2 is 2. Reciprocal of radical 3 over 2. Okay, reciprocal of this one, keep in mind that was like 1 over the square root of 3, so the reciprocal is square root of 3. Okay, so 45. If you fold in your 45, sine, square root of the top over 2. Cosine, square root of the bottom over 2. Tangent, square root of the top over square root of the bottom. Cosecant, reciprocal of radical 2 over 2. Secant, reciprocal of radical 2 over 2 is, and tangent, the reciprocal tangent would be 1. 60. So sine, square root of the top over 2 would be cosine, square root of the bottom over 2. Tangent, radical 3 over radical 1 is radical 3. And then our reciprocals. You guys know where I'm getting all of these? If I fold in my 90, those of you that can, I'm going to sit here and hold my finger down. I can't. So, square root of 4 over 2.
1.
Right, 2 over 2, which is 1. Cosine, square root of 0 over 2.
0.
Tangent, square root of 4 over square root of 0. Cosecant, square root, or reciprocal of 1 is secant, reciprocal of 0. And cotangent, reciprocal of undefined is 0. So we did this once yesterday, we've done it once today. Tomorrow we may try it again. We're going to keep practicing this until everybody's got it. Are there any questions there? Okay, so now we have just a few problems left without looking at this table. Let's see if we can work these problems out. So cover up your table if you need to. So we have 2 times the cosine of 30. So for cosine, fold in your 30. Cosine is the square root of the bottom over 2, so that would be radical 3 over 2. So we just get radical 3. Yes, the 2's cancel.
I don't know why I keep thinking that you just multiply.
B. Tangent of 45 degrees. So fold in our 45. Tangent, square root of the top over square root of the bottom. So radical 2 over radical 2. Plus the tangent of 60. So if you fold in your 60, radical 3 over radical 1. How would I square that? You have to write it twice in FOIL. So 1 times 1 is 1. Plus radical 3. Plus radical 3. Plus the square root of 9, which is 3. Add like terms, 1 plus 3 is 4, radical 3 plus radical 3 is 2 radical 3. I don't want decimals. We're doing everything with radicals as much as possible. Last one. Sine squared 45 means find the sine of 45 degrees and then square that answer. So fold in 45. Sine is the square root of the top over 2. So that would be radical 2 over 2. Minus 2. Sine of 45 we just said was radical 2 over 2. Cosine of 45. The square root of the bottom over 2 is so then we said cosine 45, radical 2 over 2 squared. Alright, so if I square this, I get 2 over 4 minus, can cancel one of those 2's. The square root of 2 times the square root of 2 would be 2. Divided by 2 is this one, when I square it, we also get 1/2. So 1/2 minus 1 plus 1/2. So you'll have some of those on your homework. I'm going to be giving you class time to work today because I don't want you to just copy the numbers off that table. I want you to think about it and start practicing so you know them as we move forward. Last example for the day. These are a little bit longer. We want to find the value of each variable. So in the first triangle, we have to find A, B, C, and D. Got 4 different pieces there. So what kind of triangle is required for trig functions to work? A right triangle. Is this entire figure a right triangle? No, but we have 2 smaller right triangles within that figure. So let's look. The only triangle that I actually have a side measurement for is the one on the right. So I'm going to start there. Now, when we're doing a trig function, it has to be a right triangle, and we have to go from the acute angle. So we cannot use that 90-degree angle. If I wanted to find side B, and I'm using this 30-degree angle, from that angle, is B my opposite, adjacent, or hypotenuse? Opposite. And 12 is the hypotenuse, because it's across from the right angle. Okay, what trig function involves opposite and hypotenuse? Sine. So what that means is the sine from my angle, from 30 degrees, equals the opposite side, which is B, over the hypotenuse, which is 12. What is the sine of 30 degrees?
1/2.
Radical 1 over 2, so 1/2. So if you multiply by 12, B is 6. All right. As far as D, we have a couple options. We could do the same thing, set up another trig function. Also, in a right triangle, if you know 2 sides, what could you do to get the third? Pythagorean theorem. I don't care. Because I'm teaching you trig functions, I'll go ahead and do it that way for the purpose of our example. So, from my 30 degrees, if I'm looking for side D, that is now my adjacent. Let's stick with using the 12. 12 was the so what trig function involves adjacent and hypotenuse? So the cosine of 30 degrees equals my adjacent side D divided by the hypotenuse 12. All right, what is the cosine of 30 degrees? So So if I multiply by 12, 12 divided by 2 is 6, so we get 6 radical 3. I expect radicals, no decimals on these.
Wait, how did you do that? Oh, you just multiply everything with 12?
Well, 12 is outside the radical, so it would be like 12 squared 3 divided by 2.
Oh, okay.
So you can do 12 divided by 2. Alright, so now we found everything in that triangle. Let's go to this other side. So if I'm looking at it, you know, this is a right angle. You might know something to help yourself out here. Do you know what side A would have to be? Do you know? Okay. We have a lot of guesses, so let's work it out and see. So, from this, the only side I now know, we found out that this was 6 radical 3. Okay, so if I want to find side A, from here, A is adjacent. 6 radical 3 is opposite. What trig function involves opposite and adjacent? So I could say the tangent of 45 degrees equals my opposite side, 6 radical 3, divided by my adjacent side, which was A. What is the tangent of 45? Square root of 2 divided by the square root of 2, which is 1. So if you multiply your A over, it is also 6 radical 3. Why did we get the same measure?
Oh wait, because that's the same degrees. Shoot.
It's not equilateral, but it's isosceles. Because if this is 45, that's 45, which means those two sides are the same. But if we didn't know that, we just found it out. So it's not a big deal to work it out.
Isn't that like a postulate?
Yeah. So once you have two sides, you could do Pythagorean theorem to get the third, or we could do another trig function. Which way do you guys want me to do it? Pythagorean theorem. So it would be A, 6 radical 3 squared plus 6 radical 3 squared equals C squared. Okay, to square this, 6 squared is 36. The square root of 3 squared is 3. So we have 36 times 3, which is?
Oh wait.
Okay, so now we have to square root, so we need a perfect square. So you can break it into 36 and 6. So these problems are longer because there's so many pieces we're solving for. It's really like 4 problems right there. But you have several different options for how to do it. Any questions? The last one. Okay, so I have to start, and I'm missing something in this picture. Sorry, this is supposed to have a right angle symbol right here. Okay, so I can't start with this triangle on the right because I don't have any information about it. But if I look at this one, we do know at least one side, so we could work from there. Okay, what did you just say? How do you know P is 15? Yeah. If those sides, or if those angles are both 45, these sides have to be the same. Then how could I easily get R? Okay. What we do 225 and 2. Radical 2 for that side.
Wouldn't the next one be a 30, 60, 90 triangle?
Yeah. So the next one. Now all I know is side R. So we're looking over here, and I know this side is 15 radical 2. So if I wanted Q, from my 30-degree angle, Q would be the opposite, and the side I know is my, is it?
No, it's your opposite. It would be 10.
It's adjacent, so we'd have to do tangent. So the tangent of 30 equals my opposite side Q divided by the adjacent side, 15 radical 2. Okay, what is the tangent of 30? Square root of 1 over the square root of 3. Okay, so if I multiply that over, it would be 15 square root of 6 over 3. 15 divided by 3 is 5 radical 6. And then the last one, you could do Pythagorean theorem. I'm going to do a trig function. So if I wanted, let's say I wanted to use my 15 radical 2, my adjacent, and I'm looking for t, which is my hypotenuse. What trig function? What is the cosine of 30 degrees? Okay, if you cross multiply, we get t radical 3 equals 30 radical 2. Can't square, but we could divide by the square root of 3. So t is 30 radical 2 over radical 3. Can we leave it like that? So if you multiply radical 3, 30 radical 6 over 3, or 10 radical 6. Lots of practice with your radicals. Any questions there? Alright, so yesterday I gave you the assignment, and you have the rest of the time now